Hello, scholars. Welcome to video 2 for Gear 1. All right, so here I'm going to show you how to set up your slides for this. And again, let me restate, you're not going to be expected to do any sort of presentation to me or to the class. Um, this One of the goals of the Gear projects is to show you how you can set up your slides, right? If you're preparing for a presentation of your research, in which some cases, you'll have to do either in your classes or maybe you get a chance to present your research at a conference, all right? Uh, the gear projects will help you kind of set up those slides, okay? All right, let's get going. All right, so of course, the first slide you want there is a title slide, and you want, you can keep the title pretty simple, or you can be descriptive, more so than what I have here. But pretty much the number one rule is to make it easy to read, right to the point. Don't put a bunch of flowery language in there, and just make it simple, right to the point. Okay, so just like this one, how moments shape distributions, right? So the person reading this is going to say, all right, well, I'm going to learn something about something called moments, and I'm going to learn something about distributions and what they look like. Okay, all right. So just again, keep it simple. If you want for your name, if you want to just add a few titles to yourself, even if you don't have them, go ahead and do that. You know, um, Robert Redford, PhD, right? You just add some titles there, right? If you want to be a doctor, put MD after your name. Okay. Imagine yourself being there already. Okay. All right. So after the title slide, usually, not always, but usually there's a purpose statement, statement of purpose, or statement of goals. Okay. And again, you want to be, pretty direct. All right. Our purpose is to conceptualize and create visual representations of variable distributions and their moments. Okay. Pretty simple. Just right to the point. All right, and then the next section is usually titled background. Sometimes it's titled literature review. But regardless of the title, you want to give your audience or your readers um, some context in which to understand the nature of this study and to understand the value of this study. Okay. All right. So here, and again, we go into a little more detail. The statements are a little more complex in their structure, but again, you want to be right to the point, right? Moments are simple mathematical functions used to describe the shape of a distribution. There are two classes: location parameters, scale parameters. Okay, and then you give a simple definition. Location parameters indicate. Okay, and then scale parameters indicate. Boom. Right? You just want to be right to the point. Okay? All right. All right. But let me say this. Regardless of what phenomenon you choose to study, even if it's something, way far different from crime rates, your background slides, um, or I'll say this, for your background slides, stick pretty close to what I have here. All right, because again, the background talks about the general purpose of your study, and so regardless of what variables or conditions you use, all right, the purpose of the study is going to be the same. Okay. All right. So again, a little more background. I think I have a couple of background slides on this, a couple more, right? But the study will demonstrate how location and scale parameters determine the shape of a distribution. Okay, right? So we start with a context, a conceptual context, all right? And then we think about how a distribution of a single variable might appear under 4 different conditions, okay? And we, instruct the reader, right? We're going to, manipulate moments, right, to show how they modify these the shapes of these distributions. Okay, when your background slides get to the actual subject of your study, so here the subject of my study is crime rate. All right, here's where yours might differ from mine, but you want to set it up pretty much the same way. Okay, so you might say something, sort of like this. This study shows how, and then insert the name of the phenomenon that you're looking at, might be distributed in a group of small cities, large cities, poor counties, right? Whatever those conditions are, okay? That's how you would just switch out a few words from this statement, okay? And then you want to, give me some, background. All right, so how are, in this case, we're looking at small versus large cities. So how are small cities different in terms of crime rates from large cities? All right. And then on the next slide, how are poor counties different in crime rates from wealthier counties or rich counties? Okay. All right. And then for the next slide, just again, it's explaining why I'm looking at poor versus rich counties. Okay. All right. So crime rates in impoverished areas tend to be very high for many different reasons. All right. And then again, so what should the shape look like? It is likely that the center of the distribution, right, the distribution for poor or impoverished areas, the center of the distribution will be located at higher crime rates and spread farther into the higher crime rates. Okay, so we'll likely see some curve that's somewhat flat, right? Because you're going to have many more uh, impoverished areas spread out across different levels of crime rates. All right. Conversely, you're going to have a distribution among rich areas. And again, this is just what I'm thinking, right? This is just what I assume to be the case. Do I know that it's the actual case? No, I don't. I'm not working on actual data. But again, folks, it's really, really important to develop the ability to take that distribution out of your head and get it into a program like SAS, right? To get it onto paper, okay? To know exactly what that thing is going to look like, all right? So again, for crime rates in rich areas, they're going to be very low, okay? But maybe there are a few rich areas that experience crime waves, okay? All right. Therefore, the center of the distribution will likely fall at the lowest levels of crime, with few areas having significantly higher crime rates. Okay. All right. So I get this tight clustering, all right, of areas, rich areas, down at the lower ends of the crime rate. Okay. And I have just a few, but just a few in the higher, experiencing higher levels of crime. Okay. All right, and then for the method section, uh, here you want to be a little more specific about exactly what you did to create this data. All right, this is especially the case. Well, I was going to say this is especially the case when you're using simulated data. Uh, but if you're using simulated data or actual data, you want your method section to be fairly specific in some details. Okay, right? So in this case, we tell the person, and yours would look pretty much the same. Um, you're going to use this exact same first bullet point. Data for this study was generated using a random number function in SAS 9.4 software. Okay, and then you're going to talk about each condition, right? Small cities, large cities, or whatever your conditions are, right? And then you're going to say the variable that you're interested in. In this case, crime rate was simulated with a beta distribution. Again, you can use the beta distribution. All right, it's I think it's the simplest type to use, or you can use one of the others that we've used before. So, um, the normal distribution or something like that. Okay, or you can use combinations. So use beta for some and use normal distribution function for others. Okay, you are not restricted. All right. In SAS, beta distribution is created by manipulating two shape parameters. Both influence the location and scale of the distribution. 1,000 observations were generated for each crime rate for each condition. Okay, you want to tell them the seed value that you used, right? All right, and then you want to be fairly specific about the variables you created. So crime one, it represents condition one. This is the crime rate among small cities. And this is how you set up the variable. Rand, beta, first shape parameter is a 1, second shape parameter is 40 times 100. Okay. And you write it out the same way here. Okay. Uh, Folks, you know, at some points you want to, you can write a little more creatively, but then there's some aspects of your PowerPoint slides or Google slides, whatever. There's some aspects of your presentation you want to just sort of write in a very direct and somewhat dry manner. Okay, be very direct on some of these things. Okay. All right, and then for statistical analysis, all right, we generated descriptive statistics. So that includes the mean, standard deviation, skewness, and kurtosis. All right, and then we generated graphs of the distributions. All right, so some of the results. All right, so again here, I don't expect you to go into a lot of detail or have any sort of lengthy discussion about each. If you want to do that, you can. All right. For this first gear project, all I'm expecting you to do is give me a results page, tell me which condition is being represented in the graph, and then show me the graph. Okay? But I want you to have this information. All right? I want you to have, for your first condition, figure 1. Okay? And then give me a title. Right? So you could say conceptualized distribution of whatever variable you've chosen, right? Among, right? Whatever that condition is. All right. And then we have, a nice histogram that shows what that distribution should look like. And again, we were expecting that in smaller cities, right, crime rates are going to typically be lower, which is what we see here. All right. Most of these small cities are concentrated in the lower levels of crime. You have a few that get pulled out over here, right? And then up here, we have mean, standard deviation, skewness, kurtosis. Okay. So title, right? The inset statements. This is what I'm looking for. I'm looking for the variable label down here. And again, the footnote. and also a more descriptive y-axis label than what SAS generally gives you. So this represents percent of smaller cities, all right, and we're looking at 1,000 cities, okay, all right. And then the same thing here. Condition 2, crime rate among larger cities. Figure 2, conceptualized distribution of crime rates among larger cities, right? Here we have um, the inset, right? Set up in a different manner, all right? If you take a look back at my um, SG plot program statements, just compare the inset statement for um, the first crime variable to the inset statement for the second crime variable, and you'll see the difference. Okay, so the things that I did differently in the inset statement for my crime two variable, right? It created this different setup for the mean, standard deviation, skewness, and kurtosis values. Okay. All right, and here we get something that's sort of approaching normality. So just like we have here, all right, as our footnote. And then the same thing here. Distribution is approaching normality. All right. All right. And then here we have something skewed to the right. We might even say heavily skewed to the right. All right. And we see how that skewness and kurtosis shows up, right, in the moments. All right. All right. So you can use pretty much the same, conclusions because you're going to see the same things, right? Simulated distributions in this study clearly show that manipulating moments can have significant effects on the shape of the distribution. Okay. Extreme values for moments typically generate distributions with extreme shapes. Okay. That's what you want to pull from this simple study. Okay. And again, folks, we're not simply trying to teach you what a moment is. We're trying to let you see um, how you take these thoughts, these theories, out of your head, and you get them on the paper, and get them to a point where you can actually test these ideas that you have about things using SAS or using other programs that you'll probably learn about. Okay. All right. So after the conclusions, you want to just copy and paste your SAS program uh, into the last slides. Okay. Doesn't have to be anything fancy. Just make sure it's legible, easy to read. All right, folks. And that'll be it for Gear 1. All right. So there's only one more thing that I wanted to talk to you about before I cut you loose here. All right. But let me be clear. All right. So the only thing you're turning in for Gear 1 are the slides that you create. Okay. That's all you're turning in to me. But you want to make sure that those slides at the last pages of your slides have your SAS program. Okay. Because what's going to happen? I'm going to copy and paste your SAS program into the same online SAS version that all of us are using, and run it and make sure there are no errors. Okay. All right. But let me just kind of say one more thing. But this you don't have to include in your slides. Okay. You don't have to include this at all. All right. All right. What I want you to remember is that when we run these simulations, uh, we're typically testing an idea that we have about reality, okay, about how reality works. And when we're testing this idea, sometimes we don't have actual data to test our idea. So what we do is that we create simulations, okay? And we use these simulations to test how plausible our idea is, right? Uh, if we find it to be plausible, we don't go tell our colleagues, oh, look, this is how reality works. I know because I ran this simulation. Um, your colleagues would probably laugh at you and they'd probably fire you from your position if you did that. Right? You're running a simulation to see how things might work. All right? After you run the simulation, it would then be your responsibility as a sincere and honest scientist, right? It would be your responsibility to try to find some data that would test that you could test against that simulation. Okay? Right? To find some real world data to see how well your simulated data matches up with the real world data. Okay? All right. So now you might think, all right, well, if you have the real world data, why even do the simulation? Just go ahead and test it. And of course, folks, that's what typically happens. Okay, but the real value of simulations is this, right? Some parts of the simulation, uh, we can go out here, we can find real world data for it, okay, and we can test that part of the simulation against real world data. But sometimes we're interested in something where we don't have the real world data, and we're sort of left to guess what that part of reality looks like. Okay, right? And so that means you don't have the real world data, right? You don't have it. And maybe you can't even get it, right? But you still need to know what that part of reality looks like. So the next best thing is to run the simulation. Okay. All right. So it's not a trivial exercise that I'm asking you to do here. It's something that is pretty important. Okay, it's a pretty important part of your intellectual development. All right. All right. So like I said, folks, if you run into some trouble, please just let me know. All right. All right. We'll see you later.